Let's see the question number 1 of this exercise. Given that E and F are such are events such that probability of E equal to 0.6, probability of F 0.3, and probability of E intersection F equal to 0.2. Find probability of E by F and probability of F by E. Let's see the solution of this question. So we recall the relevant formula. We know that probability of E by F equal to probability of E intersection F by probability of F. Now putting the value of this one and this one from the question, then we get 0.2 by 0.3. After simple calculation we get 2 by 3. So this one will be the answer of this one. Similarly, we recall the relevant formula for this one. Probability of F by E equal to probability of E intersection F by probability of E. Now putting the value of probability of E intersection F and probability of E from the data. So this one will be 0.2 by and the probability of E equal to 0.6. So we cancelled out the decimal, then we get here 2 by 6. After the cancelled out the common factor, we get here 1 by 3. So the required answer of this question will be 2 by 3 and 1 by 3. So this one will be the answer of this question. However, there is no problem to understand the solution of this question. Let's listen once again. Let's see the question number 2. Compute probability of A by B. If probability of B equal to 0.5 and probability of A intersection B equal to 0.32. Let's see the solution. We recall the relevant formula. So we know that probability of A by B equal to probability of A intersection B by probability of B. Now putting the value of probability of A intersection B and probability of B, then we get here 0.32 by 0. We write down here 50 equal to, here will be, we cancel out the decimal, then we get 32 by 50 equal to, here will be 64 by 100. Therefore probability of A by B equal to, here will be 0.64. So this one will be the answer of this question. After, there is no problem to understand the solution of this question. Let's see the question number 3. In question number 3 we have 3 questions. This is the question number 3. If probability of A equal to 0.8 and probability of B equal to 0.5 and probability of B by A equal to 0.4. So ask us find A probability of A intersection B and probability of A by B. Ask these 2 questions, 1 and 2. Let's solve question number 3. In this question, ask us find probability of A intersection B probability of A by B, and third, probability of A union B. Let's see the solution. Probability of B by A equal to probability of A intersection B by probability of A. Now putting the value of probability of A intersection B and probability of A, so and probability of B by A, so probability of B by A is 0.4, probability of A intersection B is not given, and probability of A is 0.8. So now from cross multiplication we get here probability of A intersection B equal to 0.4 into 0.8 equal to 0.32. So this is the solution of first part of question number 3. Let's see the second part of question number 3. So probability of A by B equal to, we write down here, probability of A intersection B by probability of B. So here will be probability of A intersection B, we find out here 0.32 by probability of B from question it is 0.5. so after decimal we have 2 digits, so here we also write down after decimal 2 digits, then here will be 32 by 50, we cancelled out the common factor, then this one will be 16 by 25, so we write down here 16 by 25. So this one will be the answer of the second part of this question. Let's see the third part. So probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Now putting the value of all of these three, so the probability of A is 0.8, so we write down here 0.8, and probability of B is 0.5, so we write down here 0.5 minus probability of A intersection B, we find out here 0.32. After simple addition and subtraction we get here 1.32 minus 0.32, here will be 1.30. so after the subtraction we get here 0.10 minus 2 equal to 8, and here will be 12 minus 3 equal to 9, so 98. So this is the solution of first part of question number 3. This is the solution of second part of question number 3, and this is the solution of third part of question number 3. Hope that there is no problem to understand the solution of these three part of question number 3. Let's solve question number 4. Question number 4 asks us evaluate probability of A union B. If 2 times of probability of A equal to probability of B equal to 5 by 13, and probability of A by B equal to 2 by 5. Let's see the solution. So here probability of A will be 5 by 13 into 2 equal to 5 by 26. Again we recall probability of A by B equal to probability of A intersection B by probability of B. After there is no problem to understand up to this step, we recall the formula for this one. So now we putting the value of probability of A by B equal to 2 by 5. So we write down here, or 2 by 5 equal to probability of A union A intersection B is not given. By probability of B equal to 5 by 13. Therefore, here will be probability of A intersection B equal to 2 by 5 into 5 by 13. We cancelled out 5, then we get here 2 by 13. So now we recall probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Now putting the value of probability of A, which is 5 by 26, so we write down here 5 by 26 plus probability of B equal to 5 by 13 minus probability of B A intersection B equal to 2 by 13. The LCM will be 13. LCM will be 26. So here will be 5 plus 10 minus 4. 15 minus 4 equal to 11 by 26. So this one will be the answer of this question. After there is no problem to understand the solution of this question. Let's solve question number 5. This is question number 5. If probability of A equal to 6 by 11 and probability of B equal to 5 by 11 and probability of A union B equal to 7 by 11. In this question ask us find number 1 probability of A intersection B and probability of A by B and probability of B by A. Let's solve first part of question number 5. Let's see the solution. For this we recall this formula. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Now putting the value of this one from question, this one is given 7 by 11 and probability of A equal to 6 by 11 plus probability of B equal to 5 by 11 minus we write down here, this is not given, and ask in this question probability of A intersection B. Therefore probability of A intersection B equal to 6 plus 5 equal to 11 by 11, it means that 1, so we write down here direct 1 and this one move in the right hand side, then we get 7 by 11. So here will be 11 minus 7 equal to 4 by 11. This is the solution of first part of question number 5. Let's see the solution of second part of question number 5. Probability of A by B equal to, we write down here what? Probability of A intersection B by, we write down here probability of B. Now putting the value of we find out probability of A intersection B equal to 4 by 11, so we write down here 4 by 11 divide probability of B is 5 by 11. So next step here will be 4 by 11 into 11 by 5 equal to 4 by 5. So this is the answer of the second part of this question. Let's see the third part of this question. Third part of this question asks us probability of B by A equal to, we write down here probability of A intersection B by, we write down here probability of A. After putting the value of these two, probability of A intersection B equal to 4 by 11, so we write down here 4 by 11 and divide probability of A equal to 6 by 11, so we write down here 6 by 11 equal to, here will be 4 by 11 into 11 by 6, so this one cancelled out and we cancel the common factor, 2 2 is 4 and 2 3 is 6, so here will be 2 by 3. So this one is the answer of the first part of this question, probability of A intersection B, and this one is the answer of the second part of this question, probability of A by B, and this one is the answer of the third part of this question, probability of B by A. Hope that there is no problem to understand the solution of these three parts of question number 5. Let's see question number 6. In question number 6, ask us a coin is tossed 3 times where first head on third toss, event E, and event F heads on first 2 tosses. Let's see, first of all we find out the sample space. Sample space, it means that will be S, and a coin is tossed 3 times, it means that it will be H, 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 and H, H, T, H, T, T, and T, 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 and T, H, H, and 1, 2, 3, 4, 5, and T, H, T, 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 H, H, T, H. So 1, 2, 3, 4, 5, 6, 7, 8. So sample space has 8 sample point, or this one is known as the number of sample space. Here will be 8. After there is no problem to understand up to this step. To clear more easily, we take the help of this one also. It means that S equal to Cartesian product of HT into HT into HT. So after the Cartesian product of this one, we get this one. So this is the sample space. For the same sample space, we have 2 events. So event E has head on third toss. It means that this one, this one, this one, and this one. So head on third toss, head on third toss, head on third toss, and head on third toss. It means that 1, 2, 3, 4, or we write down here H, 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 head on third toss, and we write down T, H, H, and we write down TTH, T, T, H, and we write down here H, T, H. So here will be number of E equal to 4. 1, 2, 3, 4. After there is no problem to understand up to this step. Now we find out F. So we write down here F. Event F is saying that heads on first 2 tosses. It means that it will be head and first 2 tosses. It means that this one. this one, only these two. So we write down here H, H, H and H, HT. So this one will be number of F equal to 2. Observe there is no problem to understand up to this step. Now we find out E intersection F. Then E intersection F will be HHH and HHT. So only we write down HHH. So this one will be what? Number of E intersection F equal to 1. After there is no problem to understand up to this step. So we find out probability of E by F equal to probability of E intersection F by probability of F. So the probability of E intersection F will be just like number of E intersection F by number of S, and probability of F equal to number of F by number of S. So we cancelled out number of S, then we get number of E intersection F by number of F. So here will be number of E intersection F is 1 and number of F equal to 2. So probability of E intersection E by F equal to 1 by 2. However, there is no problem to understand the solution of first part of question number 6. Question number 6 has 3 parts. So however, there is no problem to understand the solution of first part of question number 6. First of all, we find out what is the sample space. After that, we find out number of S, and we find out what is E. So according to the given condition, head on third toss, it means that head in all 3 toss, head in third toss, head in third toss, and head in third toss. F, event F heads on first 2 tosses, it means that first 2 toss. Third toss has also head. First 2 toss. Third toss has tail. So number of F equal to 2. E intersection F. We find if we ask us find out the probability of E by F, then we need E intersection F. We find out E intersection F. So we have common sample point in E and F is HHH. So number of E intersection F equal to 1, and we know that, see here, we know that probability of E, we write down number of E by number of S. This formula is applied for here, so we write down number of E intersection F by number of S, and for this one we write down number of F by number of S. We cancelled out number of S, then here we get number of E intersection F by number of F. So number of E intersection F is 1 and number of F is 2. For more details, attend online live class of Join for Education in Google Meet. Let's see the second part of this question. Let's see the second part of question number 6. So here first of all we find out what is the sample space. So sample space will be a coin is tossed 3 times. So we write down H, 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 T, H, T, T, and T, H, H, T, H, T, 1, 2, 3, 4, 5, and T, T, H, 1, 2, 3, 4, 5, and 6, H, T, H, and T, T, T. So this one will be the sample space. When a coin is tossed 3 times, then we get sample point of the sample space, all of these. So here number of S will be 8. E at least 2 heads. It means that we write down here at least 2 heads. So it has 3 heads, so at least 2 heads this one, at least 2 heads, and at least 2 heads. So 1, 2, 3, and it has also asking at least 2 heads. It means that it has 3 heads. So 1, 2, 3, 4. So we write down here E equal to H, 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 T, T, and T, H, H, and here will be H, H, T. So here will be number of E equal to 4, and event F has at most 2 heads. So F at most 2 heads. It means that we leave this one only, and we write down all of. So we write down here H, H, T, H, T, T, and T, H, H, T, H, T, and T, T, H, H, T, H, H, T, H, and we write down it. Asks us at most, so we also write down 0 heads, T, T, T. So here will be number of F equal to 1, 2, 3, 4, 5, 6, and this is the 7. Now we find out probability of E by F. We also read this one in this way: probability of E when F has taken place. So this is the conditional probability. So we write down here probability of E intersection F by probability of F. So we find out here what will be the E by F. So here will be E by F equal to what are the common in E and F. So we have encircle by green color the common sample point. So HH is not in here. HTT all this one is here. TTH see here TTH HHT. So let's see here HHT is not here. So see here HTT. So this is the HTT, and HH is also not here, and HHT is here. So only three sample points are common. So we write down here by blue color H HT HTT T and T T H. So here will be number of E intersection F equal to 3. So conditional probability of E when F has taken place, we also read this one: probability of E by F equal to probability of E intersection F by probability of F. So we write down here number of E intersection F by number of F. So we write down number of E intersection F is 3. So we write down it here 3, and number of F is 7. So we write down here 7. So this one will be the answer of this question. However, there is no problem to understand the solution of second part of question number 6. Let's see the third question of question number 6. Question number 6 has 3 parts. So question number 3 of 6 is saying that at most 2 tails, and F is an event at least 1 tail. So first of all we find out what is the S. S means a coin is tossed 3 times, then we get the S. So when we toss 3 times a coin, then we get H. This is the first sample point. HHT, this is the second sample point, and HTH, third sample point, HTT, and THH, THT, TTH, and at last T T. So here number of sample space will be 1, 2, 3, 4, 5, 6, 7, and this is the 8. After there is no problem to understand up to this step. So E is the event saying that at most 2 tails. So at most 2 tails, it means that we write down here 0 tails to 2 tails. 0 tails, so here 0 tails. So we write down here H, 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 1 tail, and 1 tail. So we write down all of only we leave this one T T T. So we write down here 1, 2, 3, 4, 5, 6, 7. So all sample point except T T T. So here number of E will be 7. After there is no problem to understand up to this step. So event F is saying that at least 1 tail. At least 1. So see by green color. At least 1. So it has 0 tail, 1 tail, 1 tail. So it has at least 1, but it means that 2 tail, 1 tail, 2 tail, 2 tail, and this is the 3 tail. So here will be F equal to HHT, HTH, HTT, and THH. So we write down except all element HH. So 1, 2, 3, 4, 5, 6, 7. So F has also 7. So we write down here H, H, T, or we write down all sample point except H, H, H. So here number of F will be also 7. After there is no problem to understand up to this step. Now we find out probability of E by F. So we need E intersection F equal to what? So here E intersection F will be 1, 2, 3, 4, 5, 6. So the common sample point will be E and F. This one is not here, and TT is also not here. So only 6 are common. So we write down here H, H, T, or all sample point except H, 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 and T, T, T. So here will be what? Number of E intersection F equal to only 6. 1, 2, 3, 4, 5, 6. So we write down here 6. After there is no problem to understand up to this step. Now we find out probability of E by F. We direct write down here number of E intersection F by number of F equal to, here will be number of E intersection F equal to 6, we write down here 6, and number of F equal to 7, so we write down here 7. So answer will be 6 by 7. So hope that there is no problem to understand the third part of question number 6. So I have solved first part of question number 6, second part of question number 6, and third part of question number 6. Let's see question number 7. Question number 7 has two parts, first part and second part. Question number 7 saying that two coins are tossed once. So first of all we find out sample space. So sample space will be H, HT, TH and TT. So the number of S here will be 4. Hope that there is no problem to understand up to this step. Let's see the first part. First part is saying that tail appears on one coin. It means that E event E, sample point of the event E will be tail appear on one coin. It means that this one and this one. So we write down here HT and TH. Let's see event F. Event F is saying that one coin saw head. It means that this one and this one. So we write down here HT and TH. Hope that there is no problem to understand up to this step. So we find out E intersection F will be HT and HT. Now we find out number of E equal to 2, number of F equal to also 2, and number of E intersection F equal to also 2. Hope that there is no problem to understand up to this step. So we write down here probability of E by F equal to, we write down here number of E intersection F by number of F. So number of E intersection F is here 2, we write down here 2, and number of F is also 2, so we write down here by 2. After cancelled out we get 1. So this one will be the answer, or 1 will be the answer of first part of question number 7. Hope that there is no problem to understand the first part of the question number 1. Let's see the second part. In second part, event E has the sample point no tail appears. It means that only it has head. So we write down H no tail appears. Event F has a sample point no head appears. It means that tail. So E intersection F will be 5. So we write down here number of E equal to 1, number of F equal to 1, and number of E intersection F equal to 0. So probability of E by F equal to, we write down here number of E intersection F by number of F. Now putting the value of these two, then we get here 0 by 1 equal to 0. So 0 will be the answer of the second part of question number 7. After there is no problem to understand the solution of these two part of question number 7. This is the question number 8. Question number 8 saying that a die is thrown 3 times. Event T, 4 appears on third toss. Event F, 6 and 5 appears respectively on first 2 tosses. So the sample point of this experiment will be, we write down here 1 1 1, and at last it will be 6 6 6. So it means that number of sample point, it means that number of S will be 6 into 6 into 6 equal to 216. After there is no problem to understand up to this step, it means that we get all of these 3. Apply the Cartesian product of this one, 1 2 3 up to 6 into 1 2 3, or we write down here middle bracket, up to 6 into 1 2 3 up to 6. After the Cartesian product of this one, we get all of these sample point. So the number of sample point here will be 216. Hope that there is no problem to understand number of sample point. Now we find out E, or sample point of E. So sample point of E will be 4 appear on third toss. It means that we write down here 1 1 4. So 4 appear in third toss. Similarly 1 2 4, 1 3 4, and so on. And at last we get here 6 6 4. So these are the sample point. We write down here dot 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 dot. So we pick out all from here, from the sample point of the sample space. We pick out all sample point in which we have 4 in third toss. After there is no problem to understand up to this step. Now we find out sample point of event F. Event F is here saying that 6 and 5 first 2 toss. 6 and 5 appears respectively on first 2 tosses. It means that here will be 6 5 1 and 6 5 2, and at last we write down 6 5 6. 6 5 6. So we need here number of f. So here number of f will be what? Let's counting 1 2 3 4 5 6. So number of sample point for event f will be 6. Now we find out E intersection f. So here E intersection f will be only 6 5 4. 6 5 4. So we write down here 6 5 and 4. Only this one is the common, both E and F. So we write down here 6 5 and 4. So here number of E intersection F will be 1. After there is no problem to understand up to this step. Now we find out probability of E by F. So we write down here number of E intersection F by number of F. Now putting the value of this one, so number of E intersection F is 1, so we write down here 1 by number of F is 6, so we write down here 6. So this one will be the answer of the question number 8. After there is no problem to understand the solution of question number 8. Once again I repeat, a die is thrown 3 times. It means that we get 1 2 3 dot dot 6 into 1 2 3 dot dot 6 into 1 2 3 dot dot 6, because we know that a die has 1 to 6. For 3 times we find out the Cartesian product of 1 2 3 dot dot 6 up to 3 times, then we get this one. So the number of sample point in the sample space will be 216. Event E is saying that 4 appear on third toss. So we pick out all of the sample point of the sample space in which we have 4 in third toss. Then we get these sample points. Event F is saying that 6 and 5 appears respectively on first 2 tosses. So we pick out all of the sample point from sample space in which we have 6 and 5 first 2 tosses. Then we get this one. After that we find out E intersection F. So we have only one common sample point, that is the 6 5 4. So the number of sample point in E intersection F is 1. Now we recall probability of E by F equal to number of E by F by number of F equal to, now putting the value of number of E by F, which is 1, and number of F is 6, so we get 1 by 6 as the answer of question number 8. After that there is no problem to understand the solution of question number 8.